So this is our last video in our week 11 concepts. So first thing I just want to show you is that the notation looks a little different. So just know that the notation is going to change a little. When you see f of x or g of x, let me get a different pen here, or p of x, all these just mean is y. Okay, so I don't have to write this as f of x equals 4x plus 5. I could rewrite that as y equals 4x plus 5. Okay, I could replace this f of x with just y. Then it looks a little cleaner. And now we're back to just working out a function table. This time they're going to ask us to insert different numbers in for x. And so we're just going to do that. We're going to try with the -1. So y equals 4 times -1 plus 5, right? That's -1 in for x. So 4 times -1 is -4 plus 5. So y is equal to 1. So that's going to be an answer there for us is going to be 1. We'll put a 0 in for x. Y equals 4 times 0 plus 5. So y equals 0 plus 5. Y equals 5. Okay, so that's going to be a 1. That's a 5. Let's try a 3. Y equals 4 times 3 plus 5. Well, that's y equals 12 plus 5. And that means y is equal to 17. Okay, so we're going to just keep going. We're going to put a 4 in there. Y equals 4 times 4 plus 5. That's y equals 16 plus 5. So y equals 21. And we'll put a 5 in there. Y equals 4 times 5 plus 5. Y equals 20 plus 5. So y is equal to 25. So you're basically just going to be substituting in 1, 2, 3, 4, 5 different x values and seeing what comes out for the y. And notice f of x is up here and x is here. You can just think about that as y in your mind. So you're not doing anything different than you've already been doing for this entire week of homework. Plugging and chugging. All right, I want you to try one on your own. All right, they're going to give different x values to go into this function. Remember, this is just y. Remember, you can write that as y equals -5x plus 4. So pause the video, come back, and check your work. Okay, to make this video a little shorter, I went ahead and wrote out all of these equations with the different x values substituted in. So hopefully you're matching me. I did this kind of quickly, so it's possible I made a mistake. Hopefully not, but I was moving kind of fast here because I know these videos tend to get kind of long. Okay, let's see what else is happening here. All right, evaluating functions, linear, quadratic, or cubic. Okay, so I'm going to try to just help you out with this here. We've got two different functions, one here and one here. And you can think about these as just writing y equals if you want. But be careful with doing that because where it says find f of -4 and g of 4, f of -4 means they want you to put -4 into for x into the f function. See that? This means they want you to put 4 into x for the g function. So let's just be very careful here. Let's sort this out. Let's start with this first one. F of x equals 4x squared minus x. And they want you to take -4 and put it in for x. That's when they say find f of -4. They want you to find what's happening with the function. Let me write that out. What's happening with the function when x is equal to -4? Okay, so be careful. We're going to rewrite this. We know this is the f function right here. We're going to rewrite this f of x as y equals 4. Now they want you to place -4 in for x. So I'm going to put parentheses around it. Minus x. So you're going to actually substitute it in twice. Notice there's two x's here. So you're going to put that -4 here and that -4 here. And when you put a number in for a letter, it's always good to put parentheses around what you're substituting in. So We're going to take care of -4 squared first. So -4 times -4 is 16. So this turns into y equals 4 times 16. Two minuses touching become an addition. Okay. Next up, we need to multiply 4 times 16 and then add 4 to it. All right. So I'm going to grab my little calculator here because I don't want to make a mistake if I don't need to. So 4 times 16 is going to be 64 plus 4. So that's going to mean y is equal to 68. Okay. Now the other one, it says use the g function, but I want you to put 4 in place of x. So the g function, g of x equals negative 5x minus 1. We're going to put this 4 in for x. So y equals negative 5 times 4 minus 1. Y equals negative 20 minus 1. So y equals negative 21. Right there. All right, let's try this again. Let's see here, with one more practice problem. Oh, they do say linear, quadratic, and cubic. So let me show you the difference kind of if we take a second here. Let's go y equals 2x, y equals 2x squared, y equals 2x cubed. Okay. So when your x doesn't have anything above its head, and there's just a 1 there, it's kind of like a 1 that's understood. This is a linear equation. It'll make a line if you graph this. In fact, we've been graphing lots of these. If there's a 2, it means it's quadratic. And if there's 3, it means it's cubic. So just a little kind of handy little notation thing that might help you as we progress further into this unit. Okay, we've got another one here. Oopsie. Evaluating functions, linear, quadratic, and cubic. Okay, let's look at this. This guy has an x, and there's only a 1 above its head, so this one's linear. This one has an x with a 3 above it, so this is cubic. So this is a cubic, this is linear. Okay, now this says use the f function, put -6 in for x. Okay, we can do that. So f of x equals 2 times -6 minus 3. Okay. And so if you don't like f of x, you could just say y equals, this becomes -12 minus 3, y equals -15. Okay, so when you put -6 into this function, the output is -15. So in with -6, out with -15. Let's try it with the g function. The g function says put -4 in for x. So what's going to happen when x is -4? What's y? Question mark. So we have g of x equals -3x cubed, oopsie, minus 2. Y equals, we'll just write it as y equals -3 times -4, but it's going to be cubed minus 2. Okay, let's take care of -4 cubed first. That's -4 times -4 times -4. So negative times a negative makes a positive. Positive times a negative is going to make a negative. So I know this is going to be a negative. And then we're going to do 4 times 4 times 4. We've got 4 times 4 times 4. That's going to give us 64. And it's going to be negative. All right, so that takes care of -4 cubed. But we still have -3 times that -64, which is -4 cubed, minus 2. Okay, so order of operations says we're going to do 3 times 64, or -3 times -64 is going to be 192 minus 2. So 192 minus 2 is 190. So that's going to be the 190 right there. Okay, so all of this is sort of leading to when do you use this in a real world situation? Okay, so we have a couple examples to practice with today. I believe those are the last two. Yep, past two types of problems for this week. Okay, a A railroad crew can lay 6 miles of track each day. They need to lay 162 miles of track. The length is in miles that is left to lay after D days is given by the following function. So the length in miles times D days is going to be equal to 162 minus 6D. Okay, so let's write this out here. L of D, which is just fancy notation, you can think about that as Y, equals 162 minus 6D. So we could write this as the length is equal to 162, and assuming that's miles, right? Minus 6 days, 6 times the day, or 6 times the day. Okay, how many days will it take for the crew to lay all the track? And how many miles of track does the crew have left to lay after 19 days? We're going to tackle this one first. Okay. Okay. So we're going to put 19 in for days. So we'll be able to figure out the length. The length is equal to 162 minus 6 times 19 days of work. All right, so I need to break out my calculator and figure out what is 6 times 19. So 6 times 19 is 114. So the length after 19 days of work is equal to whatever 162 minus 114 is. So the length is 48 miles. So that's going to go right here. Okay, let's tackle part A. I kind of did this in reverse, but there's a method for my madness. Okay, on this problem, they gave us the days. They gave us how many days to substitute in. But now they're asking us how many days is it going to take? So this becomes the question mark to lay all of the track. They need to lay 162 miles of track. So that's going to go in for the length here. So we know that they need to lay 162 miles of track, and that's going to be equal to 162 minus 6 miles times the days. So we're going to solve for D. All right, I think that's what we're going to do here. Okay, so actually the length, L times D, it should actually be 0. Okay, so let's think about this for a minute. Why is that? Because all the track would be laid when there are 0 miles left. Okay, so I need to put 0 in for right here for basically Y. Okay, so Y is going to be 0. When there's 0 miles of track left, then we need to know how many days is that going to take. So if we write this as 0 equals 162 minus 6D, all right, we can add 6D over to the other side. So we're left with 6D equals 162. And we want to know how many days, so divide by 6. So days is equal to 162 divided by 6, which is 27 days. All right, so that's going to be 27. Okay, let's try one more of these because there's a few different iterations in this sort of last section of ALEKS. We have Carmen wants to save $900 to buy a TV. She saves 17 each week. The amount A in dollars that she still needs after W weeks is given by the following function. Answer the following question. Okay. If Carmen still needs $594, how many weeks has she been saving? Okay. And how much money does Carmen still need after 7 weeks? Okay, let's try doing the first one first. If Carmen still needs $594, how many weeks has she been saving? Well, we need to know what W is, so let's put 594 in for A of W. That's going to be the amount of money that she saved after a certain amount of weeks. So if we know she saved 594, we'll solve for W and figure out how many weeks is it going to take, or how many weeks has she been saving already. So 594 equals 900 minus 17W. Okay, that looks terrible. Let's try that again. 594 equals 900 minus 17W. Okay, let's subtract 900 to the other side. All right, so we have 594 minus 900, that's gonna put us negative. 594 minus 900, leaving us negative 306 equals negative 17W. We want to know how many weeks, so divide both sides by negative 17, which is going to work out in our favor, because a negative divided by a negative is going to give us a positive 18 weeks. So Carmen's has been saving for 18 weeks, and that's how she's got $594. Okay, so 18 weeks. And if we want to, we could even substitute that in and just double check that. So watch this, 900 minus 17 times 18. Well, 18 times 17 is 306. So 900 minus 306, see what that is. I think we kind of know what that's going to be, is the 594. Yay. How much money does Carmen still need after she's been saving for 7 weeks? Okay, this time they're giving us the weeks. We're going to put that in for W and figure out the money. So that money is going to be equal to 900 minus 17 times 7. Well, let's figure out what 17 times 7 is. A of W equals 900 minus $119. All right, 900 minus $119 is going to be $781. Okay. So she's saving $17 each week. She knows the TV is 900. So after 7 weeks, she has saved, well, after, how much money does Carmen still need after 7 weeks? She's going to need another $781. Okay, because she's been saving $17 a week times 7. The TV costs 900. 900 minus what she saved after 7 weeks is equal to what's left. Okay, so that ends this recording. And please feel free to email me if you have any questions. Bye.